Welcome everybody. In this short video, we're going to be looking at for loops in Python and as well as lists in Python. Okay, these are two things that get used a lot together in Python, and they will get used in Pygame as well, which is where we're heading. So we want to make sure that we have seen a lot of the common code blocks kind of naturally in Python before we see them in the context of a game engine, which is going to have its own new things to get used to. So we want to try and build up our understanding of some of these things that we've seen in other languages like Scratch and with the Arduino. So we haven't actually seen a list before. It's not too complicated. The main thing that we want to see is how the loops and the lists work really well together in Python. Okay, so the first thing I'll do is open up a new file. So I'm going to click on my plus icon here, and I'm going to call this for loops and lists.py. So I'll press enter to start this up. And I want to just highlight what we've seen with for loops before. So for loops, it's repeating for a certain number of times. So it's a number that you already know. You need to repeat 20 times, 30 times, etc. We have seen these in Scratch. In Scratch, these were the repeat, and there was a blank times block. So we have used those within Scratch, and we've seen in the Arduino that they had this kind of complicated language that took a little while to get used to, but once you understand it, it does start to feel pretty natural to write. But it was like this: it was a for, and then we had like a counting variable, so we had to say like int I was equal to 0. Often it was 0. Then we would have to define how long do we want this loop to run for. So we would say something like, well, let's go until, whoops, pressed the wrong button. We'll go until I is like less than, say, 20. And then we would say what's going to happen at the end of each round. We would often say something like I is going to be equal to I plus 1. So what this does is this loop is then going to run starting where I is 0. And it's going to run until I is strictly less than 20. So the last time it's going to run is 19. Overall, that is 20 times. If you count 0 and go all the way to 19, you will count 20 times. Here, we're saying in the last thing, saying I is equal to I plus 1. That is an expression. We're going to see something similar in this code section today, but this is not a mathematical equation because that one wouldn't make sense as math. You couldn't have, say, like if I was 8, that would say 8 is equal to 9. That's just not true. But a single equals in programming is talking about reassigning a variable. So we're changing its value. So we're saying that I is equal to its old value, or I is reassigned to its old value plus 1 more. So that would go from 8 to 9. Also with the Arduino, we would have like curly brackets, which would indicate your code block. So we would like write code goes here or something like that in there. Now these for loops will look quite a bit more simple in Python, which is actually, most of the time just a really good benefit. Python is designed to be very readable. So you will find that some of this more complicated language is not really there in Python, which hopefully is a good thing for you. Okay, but we're going to start with lists. Okay, so lists are a variable, but they're a bit more of a complicated variable. A list is kind of like what you think. It holds many items. So it's a variable that holds many items. So most of the time, our lists are related. Okay, so for example, I'll give you one since it's a kind of school setting. We'll say that we have a list of marks. So lists are defined by, you can tell it's a list by the square brackets that go around it. So I'll write an extra little comment here, stored in square brackets. Okay, so we're going to start to fill this up with marks. This could be like one student and just all of their marks, all their different assessments in a list. Or this could be like the whole class of marks and it's just their final grades or midterm marks just all listed out. So we're going to make up some here. We're going to say they have an 80, then a 70, then a 72, Then we'll say they missed one, they got a 0, but then they felt, really bad about it. So then they locked in, they got 100 and 100 and 100, and then maybe like 95. So how many do we got there? That's 1, 2, 3, 4, 5, 6, 7, 8. Let's stop there. So let's say they had 8 marks. This is a list of 8 numbers. They're all integers here. They're not floats because they don't have a decimal. And they're all kind of related. They're all marks. So that's often how lists work. It's just a collection of very similar items. We could have another one where we had, say, like a grocery list. I'll use a capital L here for the grocery list. So just like any variable, it's the name of the variable. You get to name it, equals, and we want square brackets because it's going to be a list. So we're going to make this, say, the first thing. I always have to buy bananas all the time. So that's always top of mind when there is a grocery list. If you don't like bananas, don't judge me. I like bananas, but I also really like bananas and chocolate. They go really well together, especially when the chocolate is like melted. You put in the microwave anyway. And then, yeah, the bananas, you dip them in. It's delicious. But maybe you're someone that prefers strawberries and chocolate. That's always a classic combination. You can dip them in. Again, melt the chocolate. Lovely. Maybe you prefer dark chocolate. Maybe you find milk chocolate a little bit too sweet. You like it to be a little more bitter. Then let's say, what else goes in here? Let's have another healthy snack, these sour gummies. And let's be a little Canadian and we'll say we're going to buy some Coffee Crisp. Just the healthiest grocery list you could ever imagine. So we've got 1, 2, 3, 4, 5, 6 items on the grocery list. So again, we've got a list, which is just a collection of variables. They can be numbers, they can be words, they can be really any of our more basic data types, any of our more basic variables. But they don't need names. So we wouldn't name these like, we wouldn't have a bananas variable and put them in the list. Everything goes in here kind of in a more raw state, I guess. Because if you make a variable, then try to put it into a list, it'll actually make a copy and it's not linked the way you might think it's linked. So that's not something we would do here. We can also have a list. A list can actually contain many things. Not all programs. Lists are also called arrays, A-R-R-A-Y. They're also called arrays in other programs. And in other programs, you have to keep your array or your list as a single type of thing. But there are a few languages where you can mix up the different types. So we could have something like, if we think about a junk drawer of, computer junk drawer, what would you find in your computer junk drawer? Maybe we would find a cable. Maybe we would find some numbers hanging around. Leftover random numbers from something you generated in a previous program. Maybe there's some decimals in there, a pi, and maybe a 2.00. And maybe we have some other strings in there. We've got a stray string of variable. We have a little bit of extra code in our junk drawer. And we've got a random kind of true value just hanging around in there. This is a perfectly fine way to define a list. They just have no association to each other whatsoever. So this wouldn't really show up in most cases. It's much more common to have a list of different things that are in common. Okay. But that's really all we're going to look at for now for lists, except for one other thing. When we started, I've been counting how many things are in this list. But Python can tell you the length of a list pretty easily. Okay, so it's usually just better practice to get Python to count it for you. Because when you do more programs, like the list can get really long. Like if you're talking about analyzing surveys, you can get hundreds, thousands, tens of thousands of people respond to a survey. You do not want to count that by hand because you'll probably get it wrong by the end anyway. But Python can tell you the length of a list. It uses a function or a method. It's called len, which is short for length. So we would use len, but we have to give it an input. So we give it some sort of list that we would put inside, and it will return it back. So I'm just going to take a couple of variables, and I'm going to store the size of the marks and the size of the grocery list. So I'm going to call this mark size here, and we're going to say that's len of marks. Okay, so we have a new variable, marks size. It's just going to be a single value, and I'm asking it to be stored as the however many marks there are in that list. And we'll do the same thing with, we'll say grocery size. And that's len, and then brackets. Inside the brackets, we write whatever list we're passing in. In this case, it's grocery. Got to spell it right, though. Grocery list. And before we go any further, we've defined 3 lists. I don't know if I made an error here. I haven't really been checking. So it's a good thing to try to run the program, and also, like, we're going to print out some values. So I'm going to print out mark size, and then I'm going to print out the grocery size. Now, I have counted those already. The mark size should be 8, and I do have, I think, 7. No, it's just 6 things in the grocery size. So I'm going to press the play button and just see if that worked. We've got 8 and 6. So that's what I was expecting. So luckily, I didn't make any little typos, but it's really easy to forget a comma, to forget a end of a square bracket. Maybe we misspelled true in Python. It's a capital T for true. In other languages, it's lowercase t. So that's something I always have to, watch out for. But everything is working okay up until this point. It's always a great idea to print things out as you go, just to make sure that you're on track. I don't actually need these values, so I'm just going to comment them out. I'm going to put a hashtag out in front and comment those out. Okay, so now I do want to talk about the for loops, okay? Because in a game, you will see a for loop basically in every single Pygame file that we make, because the game is constantly looking for new inputs, right? If you think about a console game like a PlayStation or a Nintendo or a Microsoft Xbox, it's waiting on your controller input, right? And once you press, it needs to register that like super quickly. So it's just always scanning, and there's a whole list of events. So when the game engine is going, it's just always going through, scanning through all the different possible events. And Pygame will do that with a for loop. It has a list of all the events, and it scans through constantly looking for changes. Now the syntax again. The syntax that you would see in other coding languages, like the Arduino, has this kind of for and then these 3 sections where you define them. And that does get really comfortable and, once you get enough practice with it. But out of the gate, it looks very kind of intimidating. In Python, let's write for loops in Python. In Python, it is quite a bit easier. We just have a single sentence that we write. We're going to say something like this. For grade in marks, and then a colon, because we do have a code block here, just like an if statement or a while loop. So we have a colon, and then there's some indentation that's going to mark the code block. Now, okay, so I'm just going to do something simple here. I'm going to say print grade, and you should be thinking like, where's this grade coming from? So the answer is I just made that up, okay? Remember, a list contains multiple things. So when we talk about in what, this part here is the list that we're talking about. So you need to kind of make up in kind of the same way you'd name a variable in a way that makes sense for what you're doing. You want to think about, what would I call one individual thing in this marks list? Well, I would call one a grade. So I can make up whatever word I want, but this just represents one thing in the marks list. And Python will kind of take care of the rest. It knows, okay, I'm going to start at the 80. That's the first grade. Then it's going to print it, prints the grade. Then it's going to loop through again, and it's going to switch over to the 70. Print the 70. I'm going to loop through again. Then it'll get to 72. So this word here is completely made up. It does not matter what it is as long as it match. So I could put in something ridiculous like for bear in marks, print bear. This is going to work just fine. Okay, Python doesn't care about what word you pick. It's really the people that care, because you want your code to be readable. And if someone is reading forbear in marks, it's like, what does that mean? It's just confusing. But I'm going to run this. I'll press play, and we'll see that we get 80, 70, 72. These are exactly the marks we have on the list in order. So it's looping through exactly as many times as my list is, and it's just printing out each mark as it gets it. So I'm just going to close that terminal. Now I'm just going to change this back to grade, because it does actually bother me that is not very readable. And now I'm going to change this. We'll say, let's do the other list. We'll just say grocery list. So I changed it back to grade, and now this doesn't make sense because it's for grade and grocery list. There are no grades in this grocery list, but it is still the same way to write a for loop in Python. We just need to make up some sort of temporary placeholder variable that talks about what you're referring to when you talk about one single thing in the list. So when I run this code, it's going to run through and just give me printout on each separate line each of the different things in the list. So let's play that. There we go. Bananas, chocolate, strawberries. Sounds delicious. And very sugary. So I'm going to use something. I'm going to change this from grocery list, or not grocery list. I'm going to change this from grade to, let's talk about maybe an item. That would be something that would be in a grocery list. Kind of makes sense that bananas are an item in the grocery list. Chocolate is an item in the grocery list. So that reads pretty well, and I'm pretty happy with that. Item is also a really good one to use if you can't think of anything else. Item can make sense, like, a grade item. That actually makes sense too. I could have used for item in marks. And then you have a default word you can use when you can't think of anything more specific. So this will loop through, and this is the only line we have to write. So when you compare this, when you compare this to how you write it in the Arduino, I mean, it's just way more readable. And this is kind of specific, where this is how you write a for loop when you're going through a list in Python. There is a second way to write a for loop if you need to count a certain number of times, but we won't cover that one because we won't see that in our Pygame code. We'll see mostly this one where we have a list in mind. Okay, so I'm going to comment this out here because I'll maybe do a little more with this one. We'll do like an application. And I don't want this to print out the item every time. So I'm going to comment a couple of lines at once here. So to do that, I'm going to highlight all the lines I want commented. And I use a computer shortcut. It's the control and the / button, /. So the / is next to the shift on the right side of your keyboard. It's also usually shares the question mark. So I'm going to press control and / while everything's highlighted, and it will just comment, or actually uncomment, all those lines I had highlighted. And this is a shortcut key that if you program, you'll use a ton. So let's just comment that out for now. We've got the mark size and we got the grocery size. Let's use a loop. We're going to use a loop to calculate an average. Okay, if you've got a list of marks, somewhere there you're probably going to be concerned, like, what's my average? What's my average? So let's do that. We are going to use a for loop to calculate the average. So we're going to have a line that looks similar to for grade in marks. But we need a little bit of extra setup here. We need one variable. We're going to say that there's a total, and we're going to start it at 0. Okay. So this is defining a new variable called total, and we're setting its current value to 0. And then we're going to do our for grade in marks, colon. Now the next bit gets indented because this is a code block. We want to keep a running total. So we're going to redefine the total now. So we're going to say the total is now being reassigned to the old version of total, which was 0, but plus the new grade. So this works very similar to this I is equal to I plus 1 expression. We're redefining the total variable. It's equal to the old total plus the new grade as we go through the loop. Okay, so this is going to run. This is only 2 lines of code, but it's going to run 8 times here because we know there's 8 grades. So it's always good, especially when you do something like automated like this, just to print out, in this case, I'll print out the total. I need to make sure this total makes sense for what I was asking it to do. If you don't get in the habit of checking your code very frequently, it can make debugging, finding errors like really hard later. So it's always a good habit. So I'm going to run this, and we're getting a total of, it looks like 617 here. So I'm just going to put my critical thinking hat on, and I know I have 8 grades. So the maximum, if they were hundreds, was 800. And I do have 1 0, so now the max is 700. And we got some pretty high marks there, so 617 actually sounds pretty good. So I don't think anything went wrong there. So I don't need this line anymore, so I'm going to comment it out as well. But now I know that the loop worked well. So when I'm making the average, I'll just maybe adjust here in case you're not sure what the average or the mean is. It's the total divided by the number of grades. Okay, and we are actually pretty lucky because we already have how many grades there were. There was this marks size or mark size variable. So what I want to do is actually calculate the average. So we're going to make this a new variable called average, and that's equal to the total, and then we divide, which is the slash, and we're dividing by mark size. That's where we stored that 8. And then let's just print that out. Let's check to make sure it worked. Print average. Okay, so we're going to try and run this. So we should get a mark that's definitely less than 100. And we're getting 77.125. Okay, that I think makes sense. And at this point, you might be thinking like, okay, let's make a change. What if we did have that 1 0? Let's say we were being very nice and we said, okay, that's 0. We're just going to take that off. Clearly, you did really way better at the end of the course. So we'll just take that 0 off because I think it's not really showing your best, what is actually your consistent demonstration. So I'm going to remove that. And now the really great thing is that this code will update itself. Okay. Another way we could have written that was like, oh, we count it manually. So the average is the total divided by 8. But if I change how many marks were in there, now my 8 is not accurate anymore. But by using this code here where it's getting the length of the marks, this kind of updates itself, because if I change the marks list, then the length now changes and I don't have to actually change my code. And that's what you want your code to do most of the time. If you make small changes, it can, update itself. That's one of the reasons why we use so many variables in coding, is so that we can get the code to kind of work itself out and we don't have to change too much as we're maintaining it. So I'm just going to run this one more time here. So without that 0, now they've got an 88.14. That's pretty good mark. So maybe we'll do that for this particular student. Okay, so we've got the just kind of in summary here, we are going to see this more in context of a game. And again, we're going to be looping through just the set of possible events that the program is going to be listening for. We've made some lists, which we can tell they're lists by the square brackets, and there's a comma in between each item. Most of the time, your list will contain values or items that are related to each other, like they're all marks, they're all items in a grocery list. In a game setting, you could use this to store, like, for example, if you're talking about a old school kind of game like a Mario game, you do have a lot of patterned blocks that look the same, right? All the bricks in Mario look the same. All of the grass looks the same. All the clouds kind of look the same as well. And so those tiles, you might have a list of all your different tiles. Like you might have a water tile, a land tile, a sky tile. You might store all those tiles, all those possibilities in a list. So as you're going through with the game, then you can just reference your tiles list and find which one you need. That is done in something like Tetris as well, where all the different shaped blocks those are maybe stored in a list. So when you're looking at, this is block comes next, you're just grabbing a random block from your list of possibilities. So that's how a list might be used in a kind of gaming situation. And the for loop, again, it's just one single line of code in Python. That's pretty straightforward, except for the part where you have to make up one kind of variable name here, in this case grade, or if you're not feeling creative, just stick with item as default, and unless it really doesn't work, then just you can stick with item and then just use that all the time. And that will loop through a set number of times, based off of the length of your list, how big it is. And that's a really convenient and easy way to write a for loop in Python, and work with a list that way. So we'll kind of leave that one there, and we'll kind of see these topics again show up in Pygame, but that'll be it for now. Take care.